All right, let's take a look at the first derivative test. So the first derivative test is basically the use of critical points to determine intervals of increase and decrease, right? So what is a critical point? Well, a critical point, or critical points, are points where the first derivative, f prime of x, of a function f of x is equal to 0, right? These are values of x that make f prime of x equal to 0. So let's say that those points are, right, f prime of c. Let's use c for critical points, where f prime of c is equal to 0. Right, in the c, when x is equal to c, these are what we call critical points. Okay, or critical numbers, whatever you want to call them. These are critical numbers of x. Right? And what's the relevance of critical points? Well, critical points will indicate a point of extrema, really, right? So critical points can indicate points of extrema, and points of extrema, I'm going to use POE to represent points of extrema, and points of extrema can basically correlate with a maximum or minimum point, right? Now, basically, we understand that a maximum point is going to be concave up like that, and a minimum point concave down like that, right? Both of these points are going to have a slope of a tangent is equal to 0, right? So the slope of the tangent to both of these points is equal to 0, and that's why we let the first derivative equal 0, right? But furthermore, critical points can also be used to determine intervals. So what we need to understand is that when f prime of x is equal to 0, right, or f prime of c here, sorry, when f prime of c is equal to 0, then c is your critical point. But the first derivative can also tell us f prime of x, if it's greater than 0, then we basically have an interval of increase, right? So an interval of increase occurs when the graph is either concave up, sloping upwards this way, or concave down and sloping upwards this way, right? Both of these cases indicate a scenario where as x increases, y will increase, right? There's a direct proportionality. Now, it doesn't mean that it's linear, right? It's usually exponential. But you can notice here that the slope of the secant of the endpoints would indicate a positive slope, right? So overall, x and y, y would be increasing relative to an increase in x, right? So that's an interval of increase, and that's when the first derivative function is greater than 0. Now, an interval of decrease can be defined. Interval of decrease can be defined as downward sloping and concave up, or downward sloping and concave down, right? And you can notice that the slope of these secants also between the two endpoints, right? You can see that they have a negative slope, right? So it's important to understand that if f prime of x is less than 0, then therefore we have an interval of decrease. And this is really what the first derivative test entails. These three pieces of information, right, constitute the first derivative test. And we can actually use this, right? We can use the critical points to determine maximum and minimum points. We can also use the intervals of increase and intervals of decrease to look at if the point, to verify whether these critical points are a maximum or minimum. Like for instance, we see an interval of increase, right? We see an interval of increase followed by an interval of decrease, then we can understand that the point, the critical point where this is actually going to be a maximum. You can actually see that here. So this critical point here, f prime of c, well, when x is equal to c, this is going to be a maximum point. Okay? But when we have an interval of decrease and then we have an interval of increase, right, then this is basically going to demonstrate that this critical point where they meet, this critical point, let's call it c, right, f prime of c is equal to 0. At this critical point, we're basically going to have a minimum point. So this is why determining intervals of increase and decrease are really useful in conjunction with our location of critical points, because of the fact that they can actually tell us if we have a particular type of extrema, right? So this is really useful to understand, and we'll look at a few questions and how to apply this knowledge of the first derivative test.